Alright, geometry. As we continue our work on Standard 15, calculating surface area for 3D solids, we talked about prisms, and today we're going to look at pyramids. Okay, so finding the surface area of right pyramids. Finding the surface area, again, means we're finding the total area of all the faces or sides, okay, of a geometric solid. Zoom in a little bit for you here. Okay, found for a pyramid using the formula, surface area is equal to PL divided by 2 plus the base, area of the base. Okay, so again, let's better define what do P, L, and B stand for. Okay, so we have P is the perimeter of the base of a geometric solid. Okay, L is the slant height on this one. Okay, it describes the distance between the apex and the base edge. Apex and the base edge. Apex is what comes up to that point. Okay. Capital B is the area of the base of the geometric solid. Okay, whether it's a square, a rectangle, pentagon, hexagon, whatever it is, triangle. Okay, H is the height. Okay, which is describes the distance between the apex and the center of the base. Okay, so the lateral edge is going to be the distance from the apex to a vertex of the base. Okay, alright, so let me see if I have an example here. So H, the height, is this. Is on this one is shown. Okay, the height is the distance from the apex, which is this top where they all come, the faces all come together basically, and if you drop it straight down vertically. Okay, so our apex is this top point. Okay, and the lateral edge is the distance from the apex to the vertex. So for example, here is the lateral edge. Okay, slant height is this one, from the apex to the edge, that forms a right angle here. That's my slant height. Okay, so let's go ahead and identify the key features in pyramids. Alright, so for each pyramid below, shade the face that should be used as the base, and highlight and label a distance that represents the slant height. Okay, and we're going to use that cursive L for the slant height. Okay, also give the pyramid a name based on its features. So this we kind of marked is our slant height. Okay, and our base would be this one. Okay, and this could be a square. We don't really have a way to show, but a square or rectangular pyramid. Or a square or a rectangle pyramid. Okay, I don't think that we're going to necessarily be doing rectangle pyramids because then you have different lengths. So I think most of what we're going to be working with will be squares. Okay, the next one. Okay, this would be an example of your slant height, L. Okay, and then your, let me grab a different color here. Your base would be this here, which what's that shape? Is a pentagon, right? So pentagonal pyramid. So pyramid comes up to that point, the apex comes up to a point. A prism has the same shape on the top and the bottom. Okay, next one. This dashed line here gives us our slant height. Our base is down here. Okay, and again, if I count the sides, it is a hexagonal pyramid. Okay, and then the last one is actually going to be an equilateral pyramid. I'm going to say equilateral triangular. To be more specific, equilateral triangular pyramid. So here would be my base. Okay, and then this here would be my slant height. Alright, so investigate here. Alright, so to find L, okay, so to find L, the slant height, you're going to use what kind of triangle did we make by that? We are going to use a right triangle, because what can we use? What theorem? Pythagorean theorem. Okay, so you can find your slant height okay, your slanted height, if you were to drop this and then make it into a right angle. Okay, so your slant height squared is equal to the apothem squared, right? That's what, oops, I made it. Your apothem would be here, plus the height squared. Okay, so your slant height would be here. Okay, this is the height, the h they're talking about is when you drop it vertically from your apex, and then you use your apothem, so you go to the middle of one of the sides, right? That would form a right triangle here. This is your right angle. Okay, so that would be your h, your slant height, and your apothem. Okay, or you can use your lateral edge. Okay, so remember here, this would be like your lateral edge would be the side. Okay, then you would have your slant height squared plus half the base edge squared. Okay, so if that's the case, then this would be your L. This side would be your lateral edge. And then this would be half your base. Okay, I think this is probably a little more confusing than it is actually when you have numbers to work with and deal with. And we'll get to that in the examples that we're going to be doing here in just a second. Okay, so that is notes before we get to examples. Okay, for finding the surface area of right pyramids. Okay, so when we can get that right triangle in there. Okay, so we've got 4 examples where you're going to, should be able to go ahead and complete homework then. Okay, so first one, we have a square pyramid. Okay, so remember our formula right here. PL divided by 2 plus B. Okay, so to find our P, we're going to start by finding the perimeter. Okay, perimeter of our base is 6 times 4 because it's a square pyramid, so our P is 24. Okay, the area of our base is length times width or base times height, so 6 times 6, or 36. And I say del for last because we have a little bit more work usually to do with that, but in this case, my slant height was given as 10, so my L is 10. Okay, so I'm going to take P times L divided by 2 plus the base. So 120 plus 36 gives me 156 centimeters squared. Okay, remember, this is a video. You can pause it at any time. Okay. Alright, so next we can find our perimeter because we have a pentagon, which is 5 sides. So 9 times 5 is 45. Okay, my slant height is 15. Okay, and I need the area of my base. So remember, we have 5 triangles. So if I have one of the 5, okay, I need to cut that in half so I can find my apothem. Okay, by doing that, remember, instead of 9, I have 4.5 here. Okay, so I also know when I took 360 divided by 5, I get 72 degrees, and half of that makes that 36 degrees. Okay, so I can do the tangent of 36 degrees is opposite side, which is 4.5 over A. So multiplying by A and then dividing by tangent of 36 degrees. Okay, remember we're going to leave this in here, so 4.5 divided by tangent of 36 gives me an apothem of 6.1937, etc. Okay, calculator, 4.5 divided by tangent of 36. Okay, so going back to the base. Okay, remember for the base, we take our apothem multiplied by the perimeter, so 9 times 5, or 45, divided by 2. Okay, so I'm going to leave that going in my calculator. Multiply by 45, or times 9 times 5, either way, and divide by 2. So I get a base of 139.358, etc. Okay, dot, 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 it says I'm not rounding it. Okay, so surface area is P, make that a better 4, times L, divided by 2, plus the base. Okay, so I can leave that going in my calculator and add to that 45 times 15 divided by 2, right? Because these could be in whatever order. Okay, it says to round 2 decimal places, so I get a surface area equal to 476.86, and I'm in centimeters, so centimeters squared. Okay, 2 more. Okay, regular hexagonal pyramids. We have 6 sides here, so I can get my perimeter is 10 times 6. All 6 sides are 10 centimeters long, giving me 60. Okay, I need to find my slant height. Okay, so I'm going to use this triangle for that. That's my L. And I need my apothem to find that, and I need my apothem to find my base. Okay, so I'm going to actually use this to find my, I'm going to call that the hypotenuse. I'm going to use that to make this triangle here to find my apothem. Okay, and I know cutting that vertical makes that 5. Okay, 360 divided by 6, because it's a hexagon, makes it 60 degrees for this big triangle, one of the 6. Half of that makes it 30 degrees. Okay, so remember we know 30, 60, 90 exact triangles. So since that's 5, I've got 5 square root of 3 here. And if I've got 5 here, I'm going to double that to make that 10. Okay, So this is my apothem. Okay, and if I know that, and 15, so then for this triangle, okay, I can do 15 squared plus 5 squared to 3 squared equals L squared. See that second triangle in there? This is the one marked 15 in there. This is my apothem that I just found as 5 squared to 3. So that's what I'm doing now to find my slant height. So 225 plus 25 times 3. Remember, 5 squared is 25, squared root of 3 squared is 3. So 25 times 3 is 75. So my slant height is 300. Finding an exact answer means I need to do a factor tree, so I can do 3 times 100. If you see that, 100 is a perfect square, right? So then L, because I'm doing square root of both sides now, is 10 square root of 3, my slant height. Okay, so we've got P and we've got L, and I need to find the area of my base. Okay, so remember the area of the base is your apothem times the perimeter divided by 2, so 150 square root of 3. Okay, so go back to your formula, PL divided by 2 plus the base. So P times L divided by 2 plus the base. Okay, simplifying this, 60 times 10 divided by 2. Okay, because it asks for an exact answer, I get 300 square root of 3. And I have to add that to 150 square root of 3. And since they both have square roots of 3, how many do I have? I have 300 here and 150 here, giving me 450 square root of 3. And I'm in centimeters, so centimeters squared for my surface area. Those are your longest ones. Okay, those are going to be your longest ones. Okay, give me a second to absorb that. Remember, you can always pause it as well. Okay, you want to give this equilateral triangular pyramid a try, go for it. Okay, pause the video and give it a shot. Okay, this one is an equilateral triangular pyramid. Okay, so I can get my lateral height here, because I know that since this is 14, half of that is 7, equilateral triangle, right? So to get my lateral height squared plus 7 squared equals 18 squared, so my lateral is 18 squared minus 7 squared. Okay, and when I calculate that, I get 275. Square rooting it gives me approximately 16.58 something. Okay, so I can find my perimeter because it's equilateral. I take 14 times 3, right? All three sides are the same. So that's 42. Okay, and I need the area of the base. Okay, so I need to get a triangle here that's going to I need to find my height, right? So here, let me get this triangle over here. So 14, 14, and I need this height, so that is 7. Okay, remember it's equilateral, so it's 60 degrees, 60 degrees. This was 60, and I cut it in half, so it's 30 degrees. So on a 30 degree, if this is 7, that makes this 7 square root of 3. Okay, so to get the area of the base, I take base times height divided by 2, which gives me 49 square root of 3. Okay, now I've got all the pieces, so to find the surface area, P is 42 times L, which was 16.58 something, divided by 2, plus the area of the base. Okay, I know we get around, but I can only leave so many things in my calculator at once, right? So right now I've got this 16.58, etc. So I need to multiply by 42, excuse me, divide by 2 to get this side. Okay, and then I need to add to that 49 times the square root of 3. Okay, if you wanted to simplify the square root of 275 doing your factor tree, you could have done that as well, so that you could just enter in, it would be 25 times 11, so 5 square root of 11. So here you would have 5 square root of 11. So you do 42 times 5 square root of 11. Make sure that then that you divide 2 outside the radical, then plus 49 square root of 3. So final answer of 433.12 centimeters squared. Okay, so there are just 4 examples. But everything else will be along those same lines, but you should now be able to go ahead and complete your homework for surface area of right hat.